This is Walt Boyes, Editor-in-Chief of Control and ControlGlobal.com, with another episode of our Back to the Basics series for the Process Automation Media Network. This time, we're going to talk about flow measurement. We'll start with differential pressure flow measurement because, although it's one of the oldest techniques, it's still the most widely used method to measure flow in a closed pipe. A differential pressure flow meter consists of a primary element and a differential pressure flow transmitter. The primary element is a restriction in the flow path that produces a pressure drop across the restriction. This pressure drop is designed so that the square root of the differential between the inlet and the outlet of the restriction is the flow rate. That is, the flow rate is proportional to the square root of the differential. There are many kinds of primary elements: orifice plates, venturi tubes, elbows, flow nozzles, low-loss flow tubes, single-port and multiple-port pitot tubes, segmental, wedge, and V-cone elements. Each of these elements is designed so that the volumetric flow rate is proportional to the square root of the drop across the element. Some additional kinds of primary flow tubes, such as laminar flow tubes, critical flow elements, don't follow this rule, but they are exceptions. The other part of a differential pressure flow transmitter is the differential pressure transmitter itself. The upstream and downstream pressures from the primary flow elements are piped from the taps on the element to ports on the differential pressure transmitter. The transmitter measures these pressures, computes the differential between them, and usually has an integral flow computer that extracts the flow value from the square root of the differential and produces a linear analog output, usually 4 to 20 milliamps DC, and or a digital output such as HART, Foundation Field Bus, or Profibus. Sometimes this connection can be wireless. Differential pressure transmitters have been designed using many technologies, including capacitance, differential transformer, force balance, piezoelectric, potentiometer, strain gauge, and vibrating wire, and many of these techniques are still in use. The performance of a differential pressure flow meter is defined by three things. The first is the accuracy and installation of the primary element. The second is the piping of the pressure lines from the primary element to the transmitter. And the third is the accuracy and quality of the differential pressure transmitter itself. Unless the transmitter is installed incorrectly, the error contributed by the transmitter is usually the smallest part of the flow meter's accuracy concerns. The real issue is to make sure that the differential in pressure is in the upper part of the transmitter's range. Fluid characteristics play a huge role in determining the accuracy of a differential pressure flow meter installation. Be sure that the flow rate of the fluid is within the accurate flow range of the flow element. Do not oversize or undersize flow elements, even if you expect more flow in later years. And make sure that the transmitter is properly ranged too. Corrosive fluids, abrasive fluids, fluids that contain solids, and fluids that are not homogeneous and mixed are not good fluids for a differential pressure flow measurement application. Neither is the existence of significant air or gas entrainment in the flow. Diaphragm seals and other workarounds can be used, but they tend to cause significant negative effects on transmitter accuracy. The most important things to do to ensure a good application are to install the primary element correctly. It should be installed so that it can function properly hydraulically. Make sure the pipe is full of liquid for liquid flows. Vertical orientation is better. In horizontal applications, the flow elements should be lower than the downstream piping. Avoid non-condensable gas collection points like inverted U-tube arrangements. For gas flows, keep the primary flow element full of gas. Again, vertical orientation is strongly recommended. Make sure that the pressure drop is not excessive at maximum flow rates to keep abrasion down. Now, very importantly, make sure you have enough straight run upstream and downstream of the flow element to ensure accurate flow readings. The old rule of thumb of 10 diameters upstream and 5 diameters downstream doesn't always work. In the case of spiraling flows, for example, you need 100 diameters upstream if you can get them. Elbows, reducers, and valves increase the amount of run you need. Thermal wells, chemical injection points can also seriously affect the accuracy of the measurement. The piping between the primary element and the transmitter is called impulse tubing. This is another source of potential problems and measurement error. Make sure the primary element taps are connected to the right ports on the transmitter. The upstream tap should be connected to the high pressure port and the downstream tap to the low pressure port. Remember that in a vertical installation, the upstream tap is below the downstream tap. And if possible, use close-coupled installations where the transmitter is close to or connected directly to the primary element. In hot applications, you can sometimes use the impulse tubing to cool the fluid. In freezing locations, you may have to heat trace the impulse lines. Impulse tubing should be kept full of liquid or gas, whichever you're measuring. Condensation should be avoided in gas applications, but in hot vapor applications, filling the impulse tubes with condensed vapor actually protects the transmitter. For transmitters, there are some very simple installation guides too. Locate the transmitter where ambient conditions are close to normal. In outdoor installations, protect it from bright sun and from freezing or flooding. Transmitters need to be mounted to solid supports because vibration may damage them or cause accuracy shifts or errors. Calibrate the transmitter properly and zero the transmitter in the field. Finally, use differential pressure units that clearly define a pressure such as millibar or kilopascals. Don't use inches of water column or millimeters of water column. And last, be sure to open the valve between the transmitter ports when zeroing the transmitter. These are the basics of differential pressure flow measurement. We'd like to thank Spitzer & Boys, LLC for the material in this video, which came from the Consumer Guide to Differential Pressure Flow Transmitters, 2nd edition. The book can be purchased from ISA or Amazon.com. This has been a Back to Basics video from the Process Automation Media Network. I'm Walt Boys. Thanks for watching.